So first up, we have Dr. JoAnn Fites. She is a fire scientist and has some excellent research that she can share in terms of motivating you to take action. So she can give you a short bio, and really appreciate her coming. She's been traveling and probably is ready to head home by now. Thank you, JoAnn.
Thank you. So I work for the U.S. Forest Service, and my office is here locally, but I work for the regional office, and I'm a land management planner working on forest plans. But I've also done a lot of work with fire science and research, and I'm going to talk about some of that today. And I consider myself an expert on extreme fire behavior, and we're going to talk about what that means later. I try to spend my time, or I have in the past, looking at what causes that to occur and how does that affect areas that we've treated, and how are fuel treatments effective in changing those. One of the ways I've learned about that is by developing and leading a specialized team of firefighters and scientists where we would go ahead of active wildfires. We would rapidly measure the fuels, count sticks, measure the trees, the height of the trees, etc., and then set up fire behavior measuring devices like heat-triggered video cameras, etc. I learned an awful lot from that experience that I keep trying to share. So a little bit of Fire 101 to start. First of all, there are 3 different types of fires. The top left there, let's see, is a surface fire where it's just low underneath the crowns of trees. The second type is mixed fire or passive crown fire, where clumps of trees may get up into the crowns of the trees, but a lot of it's surface. And then the last one, crown fire, is actually natural in different parts of the US and Canada, but not in this area. Here, when we see that kind of fire, it's not typically what occurred, and it can damage the forests and certainly homes. So what about trends in fire? As part of my current work working on forest planning in the southern Sierra Nevada, I worked with Dr. Leroy Westerling of UC Merced, and he's an expert in modeling trends in fire, including with climate. And recently we've seen already increases in, these things are smarter than I am. Increases in the amount of area burned by 1.5, and we expect this map here, the area in red is how much increase there is. So when it's red, it's a 3- or 4-fold increase. And by the mid-2060s, we're going to see a vast increase in fire, depending upon what climate model we're looking at. Now, having said that, just because area is burned doesn't mean it's bad. If it's where we are, you know, that's not necessarily good if it's next to your home. For the forests, it can actually be beneficial if it's that surface fire. And we still have the amount of area burned is lower than it was historically. But definitely communities are affected. And fire protection is being changed. There's an increasing complexity because of that interface of homes, and the forest makes it more complex for firefighters. With dense forests, there's too many gizmos here, I'm trying here. It went off, but that's okay. Here it is. Dense forests, that means that we get more of that crown fire, and that's a lot harder for firefighters to deal with. And importantly, when we have snags, dead standing trees, and recently dead trees, we get more embers, those little pieces of burning material that spread. I'll talk a little bit about that later. Now, what about the size of fires? Are they getting larger? And what will the trends be? So we have seen not all the fires are growing as big as the rim fire or the king fire, but there's definitely some trends, and we expect those trends to continue. This is a pretty complicated graph I'm not going to totally interpret, but we expect up to a 20% or more increase in the size of large fires by the mid-century. Why? And what are some of the things that we've seen? We all know, looking at our yards, and if you water or if you just you just have plants out there, the fire season is getting longer because vegetation is drying earlier and longer and more, and so are logs. So that affects the fire season and the severity and the behavior. The drier it is, the hotter it burns, and the longer in the year that it burns. That's a trend we can all see. Now, UBNet's got a great source of latest science on there, and this is one paper that was up there from Stanford a while back, and it's about the effect of drought on trees. And the areas that are red here are ones where there's been progressive water stress in the canopy, and guess where that is? Nevada County. So that really affects how many trees are dying, but also how susceptible they are to crown fire. The drier they are, the more susceptible. So what are we seeing in terms of extreme fire behavior and mega fires? We're seeing more of it. We can't predict exactly when it's going to occur. We can't predict exactly how many, but we are seeing somewhat of a trend there. And the King Fire was one near us where it made a 50,000 acre run in one day. Will that happen here? No one knows. Might it happen here? Sure. Anywhere that has lots of continuous forest and it's dry. And part of the reason that happens is because it generates its own weather. Once it gets going and generates its own weather, then it's very difficult to predict. So what about the trends in fire severity? This is what we really care about. What we really care about is what the effect is on what you're interested in. So the definition depends on what it is. For forests, it's the amount of tree kill. We are seeing trends in the past 20 years of increasing fire severity, and especially large patches that are high severity. Not all high fire severity is bad in forests. If it's small things out there, small little pieces, that can be beneficial for wildlife habitat. Probably occurred naturally if it was less than an acre in size for the most part. But when it's large areas, that's not a trend that's healthy for forests, and certainly it's not good if your house is there. So we are seeing not only the trend in increased severity, but also the large patches of high severity. What about fuel treatments? What are we learning? So you're going to hear some more about this later this evening about just different forestry practices to make your forest healthier, which usually also means that it's better for fire and fuel reduction. But you know, treating the surface fuels either by chipping, piling, burning, removing it, that's one way to treat it. Thinning the forest, you'll hear a lot more about that. And very important is ladder fuels, those lower growing trees and shrubs that can carry fire up into the crowns of trees. So one very important thing that we know is important around homes and in the spread of fire are embers. And embers, you know, where they go, there's these little pieces like this light here. Embers that spread, and then we talk about a spotting bed, like a bed I have here. Well, this is an area that was very receptive. There were a lot of pine needles. 2 little points are burning there. Then we see them growing closer, and within the space of minutes, in this case, it erupted into a crown fire. Now, this happened to have been one of the fires we studied in Georgia, but this happens more often than you think. So what about the effectiveness of treatments during wildfires? Certainly, along an evacuation route or an area you might be going in or out, you want to use as many different tools as you can, and that'll be more effective. So when you treat the surface fuels, the ladder fuels, And the crown fuels, that's going to be the most effective, whether you thin, burn, chip, or do some pile burns. All of those things are going to be more effective. There's no doubt that if you leave it untreated over large areas, you may have clumps of this, and that's okay. Then you're going to be more likely to have crown fire. Now, one of the biggest things we've learned in these last few big fires and over the research I've done over the years is how big of an area do you need to treat to be effective when it's a big wildfire? And how far does it take of treated area before the fire changes behavior? This is very important to understand. So it may take up to a quarter of a mile for a fire to change, but it depends on the slope. So if it's steeper, then you can see this brown area around the edge. The fire would, the heat from there, it didn't kill those trees, but the heat was still going through the landscape. So you need to treat more areas in steep. So if you live in many parts of Nevada County, that means you have some steep areas near you. Safety implications. So for dead trees, one of the things to consider are embers and the stage of the dead trees. And before I even say that, I hope that one of your motivations tonight and the presentations that follow me is that you understand that it's really important to thin those trees ahead of time so you're less likely to have them die on you. That's really important. But if they are dead, you have the red needle stage. And for fires, this is when they create more embers. They burn small pieces. Crown fire is erratic. This is from the rough fire 2 years ago in the sequoia. So that is a dead tree, but live trees crown like that too. Second, when the needles fall, then you're adding to that surface fuel, and the heat and the speed of fires increase. And lastly, when they start, if they're standing in dead, first the tops fall out and the branches before the whole thing does. And that's just adding more surface fuel, increasing heat, and importantly, slowing firefighting down. In fact, whenever you have dead trees, whether they're from beetle kill or anything else, it's less safe for firefighters. They may have to fell them first before they can safely go into an area. Or if they have to cut a lot of them down, then it takes a lot of time to move them out of the way. So evacuation routes is probably one of the most important things. That's where I always start myself. Can you escape safely on your road out? And think about intensely treating with at least 10 feet. Can the trees fall out across the road? Many firefighters, I'm one of them, have had the experience where, not on our choice or purpose, we ended up in a bad situation, and the last thing you want to have happen is a dead burning tree to cross where you're trying to get out. Luckily, I always have 2 or 3 ways out, so I've survived those. And don't wait. When I say don't wait, I mean 2 things. If you know there's a fire or someone tells you to get out, don't wait. I'm not going to wait, and I know a lot about fire. And also, don't wait to work on that evacuation route until the fire comes. You always want to be prepared ahead of time.
And now I'd like to introduce Dario Davidson. He is a registered professional forester. I think a lot of people don't understand what a registered forester does. They often think of them as something like a park ranger or the campground attendant and whatnot. But registered foresters are very competent in a number of disciplines in terms of botany, wildlife habitat, archaeology, hydrology, forestry. So they really do some amazing things on the ground. And Dario has a long time been a volunteer with the Fire Safe Council, helping with our FireWise Communities program. So thanks for everything, Dario.
All right, thanks. I'm going to cover a lot of material here. I'm going to go a little bit fast so we have some time at the end for questions. And some of this you may already know, and some of it's kind of technical, and you may not follow it, but don't worry, because it took me decades to learn all this, so I don't expect you to figure it all out in one evening. So first, I'm going to briefly cover management plans. I'm not going to spend too much time on that, focusing more on the fields part of it. And then I'm going to look at individual trees and how they grow, what their needs are, and then how to assess the health of a tree by just looking at it. And then we're going to explore how trees interact with one another and the other elements in the ecosystem, because trees usually grow in groups. And then this brings us back to management plans and how to manipulate the interactions to achieve our goals and objectives in the management plan. Then I'm going to have just a couple of little scenarios as examples at the end. And I'm not going to go through anything about identification of trees, but I would like to recommend this book. It's Trees and Shrubs of Nevada and Placer Counties, and it's put out by the local California Native Plant Society. It's an excellent resource. Highly recommend it. Okay, so in a management plan, well, why do you need a management plan? Well, perhaps you don't. If you only have a few acres, you probably don't need a written management plan. But if you go through the steps of preparing the plan, at least in your head, you'll understand a lot more about your forest and what it can provide. If you manage more acres, you're probably going to need a written management plan for CEQA documents and communicating with contractors, applying for grants, etc. So when we develop a management plan, you want to learn as much as you can about the past and present conditions of your forest so you can project where your forest is headed and steer that direction. So I like to start with the property. You want to identify on the ground where your property is. Know where the corners are. Run the property lines. You do not want to spend a bunch of money and time doing treatments and finding out that, whoops, it's not even my property. So figure out where your property is, and you may be able to coordinate with neighbors and put your properties together, make a larger project that can save you money. A larger project is usually cheaper. Also investigate easements, ingress, egress, utility easements, any kind of easements. You want to know all those up front so you don't interfere with them or they don't interfere with you. So some of the resources I use are topo maps. That tells you a lot about topography, about the elevation aspects, drainage patterns. Also on the right, there's a aerial image. It can tell you a lot about vegetation and neighboring activities. The one important thing to look into is your soils, because the soil is the foundation of the forest. That information is available on the internet, and the Natural Resource Conservation Service can help you locate that information. And then you really got to get out and walk all over the forest and look at what's out there. And don't look at just the trees. Look at every feature that's out there. You may find some really interesting things. And you'll be looking for, in addition to the vegetation, you'll be looking at looking for water resources. Maybe a little spring pops up somewhere. You want to protect that. Archaeological resource. You may find some Indian grinding rocks or something. So get out and really look around. And then you can look at old stumps, and that'll tell you a lot about how fast the trees have been growing, what species are out there. On my property, I have 5 acres of, it's a lot of incense cedar and black oak, big mature trees. And when I look around in the forest, I find ponderosa pine and Douglas fir stumps, and judging from how rotten they are, probably in the 1950s, somebody did a harvest in there and took off the pine and the fir because they were the most valuable trees. They left the cedar, that grew back, and now I have a beautiful cedar black oak forest. So those kind of things can tell you a lot. And then fire scars can tell you a little bit about the fire history. Unfortunately, we don't have many of those trees left. And in my neighborhood, there's a lot of old fence lines with old barbed wire, and it doesn't make sense to have barbed wire running through a forest, because barbed wire is to keep livestock in. So I looked around some more, and I can see this big, dead manzanita. Manzanita likes full sun, and so this tells me that this wasn't a forest. It was a wide open grazing area, and then somebody abandoned the grazing, and the brush took over, and then eventually the trees overtopped the brush. So I got pretty much the whole history of the area by just poking around and seeing what's out there. So you gotta, once you understand everything you can on the ground, you want to develop your goals. What do you want for your property? What do you want to achieve? And the main ones today are reducing the fire danger, improving tree health, improving wildlife habitat. Maybe you want to grow Christmas trees or get firewood from part of the property. Just figure out what you really want. Maybe just the beauty of the forest is what you want, but you certainly want to keep it healthy. Okay, usually there's a combination of goals. Sometimes they're conflicting. A common one is we want to reduce the fire hazard, but we want to have a screen of trees so we don't have to look at the neighbor's ugly junk or look at the road. But those two things can conflict, so you have to find ways to compromise on all of those. Okay, then we tend to do inventory. This is actually measuring the trees so we know what's out there. We can quantify what our forest is. You can learn about species mixes, tree sizes, board foot volume, whatever you want. You can design the inventory. But I want to go over the measurement. We measure the diameter of the tree, and it's measured at 4.5 feet above ground. It's called diameter at breast height. That's a standard measurement. So whenever we're talking about diameter, it's 4.5 feet above ground on the uphill side. And actually, we're running a tape around the tree. We're measuring circumference, but the tape is calibrated to adjust and give you the diameter. Okay, then we also measure the heights of trees, and simply we measure back with a tape a known distance, and then we have this thing called a clinometer, and it just measures the angle to the top of the tree and the bottom of the tree, and it's just simple geometry. It gives you the total height of the tree. So then you'll know everything about your forest you need to know. Then you can start planning projects, and at that point you're going to start looking into permits, what kind of permits you're going to need, and start getting cost estimates. So that's about all I want to say about management plans. We're going to move into silviculture. Silviculture is defined as the science and art of growing and tending tree crops. That's an old definition, and nowadays we look at it more as managing the forest ecosystem. It's more than just the trees. So I want to go through, there's a little bit of terminology. I want to make sure everybody understands the components of a tree. Of course, it has roots. They're big, thick roots that support the tree in the wind. They buckle your driveway. And feeder roots, they're the fine roots that bring in all the moisture and nutrients, and they extend far beyond the base of the tree. Okay, and then right up through the middle we have, normally it's called a trunk. In forestry we tend to call it the bole, and I don't know where that came from, but that's what we say. And the bole goes all the way up to the top of the tree. And then we have this green part. It's the foliage. This is the food factory of the tree. This is what makes the tree thrive and grow, and we call that the crown. And then right at the top of the tree there's this leader, and that would be this part that's sticking straight up. That's the leader, and at the top of the leader there's a series of buds, and the one right in the middle is the terminal bud. That's the one that's going to try to go straight up. Conifers tend to try to go straight up. So one thing to keep in mind about trees is they're growing every year. They're getting bigger, expanding, taking up more space, trying to take up more resources. So they're going to grow more in height, they're going to grow more in diameter, and they're going to grow, the crown width is going to expand. So all of these trees are going to get wider and wider, and they're going to start to interlock and compete with one another and shade each other, and so they're going to start losing the lower branches. At that point, it's really overcrowded. Then when we have a group of trees, we talk about the overstory, and that's just all the trees up at the top, the ones that are dominating. And then we have understory, which is everything underneath, which can be trees, shrubs, grasses, ferns, anything. And so all this is the canopy. This is the overstory canopy. This is the understory. And to assess, to assess the health of a tree, we look at the live crown. That's the factory. So we have this thing called the live crown ratio. So it is a ratio of the length of the live crown to the total height of the tree. So this tree, about half of its total height is in live crown. So it has a 50% live crown ratio. Over here, this tree has maybe a 60% live crown ratio. That tells me that this tree has a lot of potential to produce food and grow and thrive. Okay, here's an example of a tree with a very full crown all the way around, way down low. This is about an 80% live crown ratio. And then the one on the far left, it's got a crown down low, but it's got a big gap in the crown here. It's lost all these branches due to shading. So how we compensate for that is visually we take this part of the crown and plug it in up here to fill the gap, and we come out with about a 50% live crown ratio. And then this Douglas fir in the back, it's being shaded all the way around, and it might have maybe a 40% live crown ratio. So I can tell by just looking here, this tree is growing the best, this one might be growing the second best, and that's the third best. Because the more green there is, the more potential there is for the tree to produce food. Okay, the other thing we look at is crown shape. So these trees that have really pointed tops, they're growing the fastest in height. They're reaching up fast, and they're growing the top faster than the side branches. Sometimes you'll see trees with a rounded top. Those are slower growing in height. And that may be just an old tree. They tend to slow down or round out. They can only get so tall. And sometimes it might be that the snow broke out a piece of the top and it's rounded out. So we're looking for the pointy tops, full crowns. Those are the healthiest trees out there. So then trees also grow every year in diameter. And on this one, you can see every ring represents 1 year's worth of growth. And you can count into the middle and tell how old this is. And you can also see that the growth rings are getting closer and closer together, which means this tree was growing in a forest where it's starting to compete with its neighbors, and it's getting crowded and more crowded. And by thinning, we can try to maintain a faster growth rate to keep the trees from crowding each other. So if you have a standing tree and you want to know how old it is or how well it's growing, you don't have to cut it down. There's another way to measure it, and we have a tool called an increment borer. And it's just a little drill bit, and it's hollow. And so we can attach the bit. No, I got it. Yeah. Here it is in the tree. And so then we just put this little extractor in, and we can pull out these core samples. And from these, you can count the tree rings and see how well they're growing. And I'll just pass some of these around. And it doesn't really hurt the tree. I've never seen this harm the tree. It's just a little hole, and it usually fills up with sap right away. Okay, so we can tell a lot about how a tree's growing with those tools. And different trees, in fact, all different plants have different environmental requirements, and they all require soil, water, air, sunlight, but some can tolerate shade more than others. Ponderosa pine, it likes to be out in the full sun, doesn't like to be crowded. Sugar pine's kind of in the middle there. Go on down, incense cedar, white fir, they can grow in the shade. They would grow better in the sun, but they can tolerate shade. And on the hardwoods, the live oaks, these are the evergreen oaks. They like lots of sun. Black oak, madrone's kind of intermediate. Maple and dogwood, you usually find those in the understory. And we can make another column out here for shrubs and forbs, and manzanita would be up at the top, and something like bleeding hearts might be down at the bottom, preferring a little shade. Another thing that sorts out trees is temperature regime. You ever notice when you're driving up and over the Sierra Nevada, you'll see different tree species as you climb higher and higher. And that's partly has to do with temperature regime. And so, first of all, here's an example of shade tolerance. This is incense cedar. It's the only plant growing underneath all ponderosa pine and black oak. Okay, so if you take a tree at high elevation, it's used to cold temperatures, and you bring it down lower. This is a red fir growing at 2,000 feet elevation. Red fir normally is above 6,000 feet. It doesn't like the heat, and it's not doing well. Another way you notice that is if you go into one of the big river canyons and you look on the south-facing slopes, you'll see a lot of ponderosa pine and live oak. You look on the north-facing slopes, you'll see a lot of Douglas fir. Each tree has its preference and outperforms the others on certain sites. And then another one is water. Some plants just love being near the water. Willows and alders prefer to be down there. So when we're assessing individual trees, we're also looking at what we call defect. It's some kind of damage, disease, insect problem. And this tree here has this crooked bole. That's from snow damage. This one here is forked. Sometimes the forks can break out. That could be either genetics or caused by insects. Here we have a bole scar. Could have been caused by equipment bumping up against it, similar to a fire scar. And then we have diseases. This is a common disease in ponderosa pine. All the trees have diseases that will attack them. This is western gall rust, very common. And then on the right, we have these two different trees. They're both ponderosa pines. The one on the left is just riddled with western gall rust, and the one on the right has a few infections. So each tree has different susceptibilities, and that's a genetic factor there. Okay, so that's individual trees and how to assess them. I'm going to move on to forest stands. We talk about stands when we're talking about groups of trees. They grow in groups, they start to crowd each other out, and it used to have fire to naturally keep it more open, and, oops. Oh, I forgot about the insects. Okay, you know all about the bark beetles now. So, but now we've got these overcrowded forests, and we just need to think about how to keep them more open so this doesn't happen again. Okay, so okay, what we do, when we look at groups of trees, we rate them by their crown class. So this will tell you about the health of the tree. So we have 4 crown classes: dominant, codominant, intermediate, and suppressed. And the dominants are the trees up at the top. They're getting the most sun. They're the biggest trees, the highest live crown ratio. They're the ones dominating, okay? And then we have codominant trees, which are right up there in the overstory, but they're a little bit smaller. They're not getting sun all the way around. And we have these intermediate trees that are actually getting weaker and weaker. And underneath that are the suppressed trees. They're usually crooked, damaged. They're just getting too much shade. And these trees can all be about the same age, and they'll sort themselves out like this over time. Some will dominate and some won't. The biggest question that I get from people is, how many trees should I have out there, or how far apart should my trees be? And this is what we call stocking levels. How many trees, and there's various measures of stocking levels, and I've got 4 right here. Stand density index, it's really complicated. It's used in research. We don't use that at all. Basal area is the most common one, and basal area is really just the area of the tree measured at breast height, at the same height as diameter. It's this surface area. And what we're really interested in is the basal area per acre, because that'll tell us not only about the sizes of the trees, but how many trees. So it correlates them both. So we also have what we use are spacing guidelines, and that's just, we have spacing guidelines, and that's just average distance between trees if we're going to thin out a forest, but that's based on basal area per acre. And then we have crown spacing, which is just separating the crowns so the trees have more room to grow. Okay, and basal area it's really easy to measure. We have this little tool called a wedge prism. It's just this little piece of glass you can hold in a couple of fingers, and I won't go into how it works, but it's a real quick, easy way out in the forest to measure your basal area. It'll tell you if the forest is overstocked or not. This is just an example of a forest where you can use spacing guidelines because it's fairly uniform diameters. So you can just figure out what basal area you want and then convert that to spacing and just take out the trees that are crowding out that spacing. And then this is an example of crown spacing or crown separation. It works really well in a forest that has a lot of openings and a lot of different sizes of trees because you can't really get an accurate average basal area. So we just separate the crowns. Okay, then I have this complicated chart of basal area. This is on the left, it's just geometry. This is a diameter, breast height, tree size, and how much square feet of basal area it has. But what we're really interested in is how many trees per acre of a certain size to get a certain basal area. And this can get pretty complicated, but you just want to notice that as the trees get bigger, this is 14-inch DBH, 80 basal area, as they move down this side, trees are getting larger, you're getting higher and higher basal area. And as you add more trees, you're getting more basal area. So we're trying to control the number of trees and let the other trees grow. Okay, I want to look at an example of low basal area. This is widely spaced trees because it'll have an effect on the shape of the tree. So with a low basal area, you're getting a lot of sun into the tree. So you're going to have a high live crown ratio. You're going to have a wide crown. You're going to have large diameter branches and quite a bit of taper in the bowl. And you're going to have faster diameter growth because these trees have room to grow. And you're also going to have more sunlight in, so you have more options on understory vegetation. Okay, so here I have two different tree rounds, and they're both the same age. These are both 23 years old. An important point I want to make here is that every piece of ground has a maximum potential to produce biomass. It can only produce so much every year depending on the soil and the climate. So you can have many, many little trees on an acre or a few large trees. It's one or the other. It can only produce so much. So if you take some of the little ones out, you allocate the site resources to fewer trees and you end up with trees that are larger at the same age. So here is a forest that is obviously overcrowded, and this little one that I'm holding in my hand, this little round, 23 years old, came from a forest much like this. The larger round came from a forest that was more open. It had a lower basal area and it had more room to grow. So if you want large, healthy trees, open is good. Lower basal area is what you want. Okay, I'd like to just show a few examples of historic conditions. Our forest used to be much more patchy, more open, a lot more sun hitting the ground. This is a very mature forest, but look at how much sunlight's actually hitting the ground. It's much more open than we see today. Okay, when you're managing your forest, you also want to consider some wildlife habitat elements. It's really important to give them a home. And here we have a black oak, and it's got a lot of rotten branches. It's got cavities. A lot of animals can use that. It also produces acorns, which is good food. Here we have a snag, standing dead tree. Wildlife use those a lot, but just have to be careful where you leave them and how many. They can be a hazard. On the left, we have a tree that we call a basket tree or platform tree. A lot of times you'll see nests built right in there because it's a nice sturdy platform. I've seen goshawk nests in there, and then owls will take over those nests. And on the right we have a gray squirrel nest. And then there's this piece of log laying here. A little bit of this large woody debris is valuable because critters will use that to hold a little moisture. Later in the year, salamanders will use it. But too much of that, you've just added too much fuel. So another important point I want to make about forest management is when you take any management activity and apply it or plan it, you're going to have some kind of reaction to that. And you need to anticipate that. Here is a forest that was thinned and masticated, and 5 years later, there's a lot of vegetation in the understory. More sunlight was allowed to come in, more vegetation grew up under the trees, and maybe that's okay. Maybe that was part of your management plan, but you need to think about that. Everything you do, for every action, there's a reaction, and you just need to consider that. Okay, so that's it. We can run through some simple scenarios, and you've got your goals for your property. You know your desired species mix, what stocking levels you want, where you may want openings, how much opening, understory composition, wildlife habitat, all those factors. So we can take, for example, this little chart again, and suppose your goal is just to reduce the fire hazard and improve forest health. It's overcrowded, you got too many trees, so you probably want to leave these biggest, healthiest trees, the dominants. You might want to separate a couple, maybe take out one of those co-dominants or the intermediates and the suppressed, except for maybe something for the wildlife habitat. So you're thinning the forest and you're taking out more of the smaller trees. We call that thinning from below. That's really a common prescription today. It eliminates ladder fuels. It lets more of the site resources go to the dominant trees, that thinning from below. Okay, here's an example of a forest that could really benefit. You've got really nice pointy top, full crown trees. If we take out some of the intermediate and suppressed trees, that would be a much healthier forest. It would have a lower fire danger. That would be thinning from below. Okay, supposing you have a forest and you've got some disease problem and you just want to clean it up. You just go in and pick out the dead, the dying, diseased, weak trees. That we call sanitation salvage. And that's similar to what's going on with the bark beetle issues. And then another option, maybe you've got acres and acres of just solid forest, and you want to create some openings to increase biodiversity. So maybe you'd go to some areas where the trees are a little weaker, a little more crowded, maybe there's some disease areas, and you take all the trees out of a little hole, let the sun come into the ground, and you can encourage a whole different series of plants, and animals will follow. And then maybe you can let those trees fill in those holes and grow up, and then create some other holes in the future in another spot and just rotate that early cirral opening habitat to provide more diversity. That we would call group selection. And that's about all I have. If anyone has any questions.
Okay, the question is, what is the best procedure for the safe removal of bark beetle infested trees? In other words, removal without spreading the infestation.
Okay, most of the time, by the time you notice the tree is dead, it's too late. The beetles have already left. When the tree is completely brown, all the crown is brown, the beetles are gone, they've moved on. So the best thing you can do is monitor your trees regularly, and I like to go out with binoculars and scan up and down because the beetles could be way up there. And look for the pitch tubes, look for anything, the early signs of the bark beetle infestation. If you can catch it early and get somebody in there to remove the trees and haul them off to the sawmill, you've taken the problem away. You've interrupted their life cycle. The problem today is everybody is so busy dealing with so many dead trees, it's hard to get that done in a timely manner.
All right, and the second question, what plants can be left in the understory in the fire-safe zone for homes in the forest? Deciduous, Are downed logs okay?
Okay, so if you're within your defensible space zone, you want to have it fairly clean. You want to have it the cleanest in that zone. So there are plenty of plants you can have growing in there, and they're generally low-growing, low-volume plants. The deciduous hardwoods like dogwood, maple, they can do well in some shade, but there's not much fuel on those plants. Another little low-growing one, some of those like ferns, bleeding hearts, just those low-growing, non-oily, low-volume plants. They're just fine. And then the other thing is, while you've got these trees you're trying to keep to provide shade, and they're your healthiest trees, they're going to just keep dropping material on the ground. So that's really your main thing, is to keep cleaning up the needles and the sticks, and try not to let too much stuff grow up underneath.
Awesome. Thank you, Dario. And I did want to point to everyone to the rufiresafe.com website, where we do have a full plant guide that was developed in cooperation with UC Master Gardeners. And so it's a great option for you if you're looking to revegetate in your defensible space. So Dario will be around if you have any questions. And, oh, one more question. Hang on.
So, Dario, could you just discuss the advantages and disadvantages of chipping, burning, or what we call, Justin, what do we call it? Slash and lop and scatter, yeah. Lop and scatter, burning, chipping.
Okay. Removing the fuel is the best, and burning is one way to remove it. Chipping is converting it into another form. You still have the fuel there, but it's much less flammable. There's less air in the fuel bed. So you need air and heat and oxygen to get the fire to burn, and if you get it all compacted into chips, it's less likely to burn. What I like to do is chip it into piles or windrows. It simulates like a down rotten log, and that way you don't have the continuous fuel spread all over the place. Lopping tries to do the same thing, but you never get it down. Lopping is when you cut down a tree and you cut all the branches off, you just cut it into smaller and smaller pieces so it lays down lower and lower. And so you're getting less oxygen in there. It's closer to the ground. It's going to hold moisture and decompose faster. So lopping is probably number 3 out of that, and then doing nothing, of course, is the worst.
Of course, bark beetles are a pretty popular topic. Are there any methods to kill the bark beetles? Deciduous, I'm sorry, I can't read. Oh, predator species, things like that.
Yes, there are a lot of other insects that'll prey on the bark beetles, and woodpeckers will eat them. But usually the woodpeckers get in there, and those trees that are heavily attacked by bark beetles, the woodpeckers will just chisel away on the tree and do a lot of damage to the tree. There's also, there are some treatments that you can do with insecticides, and you have to put it on the surface of the tree, and you have to have it on ahead of time. There's nothing systemic. So if the beetles try to chew their way through the bark, they eat the insecticide. It's very expensive. Really, it's only used for specimen trees, highly valuable trees.
And we do have some information on the back table from the USDA Forest Service on the pesticide treatment. So if people are interested in looking at that, it's available for you, as well as online if anyone is listening in and wants to download that. Dario, please stick around. Oh, wait a minute. We have another question. Hang on.
So, Dario, if you wanted to log, let's say you had a 30-acre parcel and you wanted to log, explain exactly how the forester relates to the logger, to, what is the procedure if you've never done anything like this? How does that work?
Okay, in California, anytime you can cut down a tree if you're not in the city limits. You can cut down a tree use it on your property, no permits required. But if you're going to sell the tree, make it into wood and sell the wood, you're going to barter it, you have to get a permit, and you have to go through the California Environmental Quality Act process. So what you would need to do, if you're going to do a project as large as 30 acres, you would probably need a timber harvest plan, and you have to hire a licensed professional forester to do that, and they would have to write like a management plan addressing all the environmental issues involved and get that approved from the state of California with 3 or 4 different state agencies involved. It's a long, slow process, but that's how we do it and assure that the environment is protected. At that point, when you have an approved harvest plan, you can contact a logger or a number of loggers and get some bids on what they'll pay you for the trees or how much they'll charge you to do the job. So the logger would be working for the landowner, and the forester could become the intermediary to direct the process and make sure that the rules of environmental protection for the state of California are followed. And the logger sometimes will find a buyer for the logs. The other option is the landowner can go to the mill and say, how much will you give me for these logs? And then they find their logger to just work directly for them. But sometimes a logger will sell the logs for you, which is, I think, is much easier.
Yeah, I think utilizing the wood product can certainly change the economics. Obviously, with a glut of blue stain pine, which is what the bark beetles create for us, the economics really aren't quite there. We do have some local loggers that are exporting to the Asian market, and so we do still have a little bit of an outlet, but you know, buyer beware. We are in a crisis here in California with the bark beetle, and so there are some people that are maybe not doing their diligence and being taken advantage of. So definitely try to make sure that you get competitive bids, deal with contractors who have a long history in our area. Fire Safe Council also has at our website a list of registered contractors that have been pre-screened by us. So whether you're looking for an herbicide applicator, a registered forester, an arborist, a licensed timber operator, you can get a directory of those locally here from our website, as well as CAL FIRE's website at fireca.gov. So, yep, one more closing remark.
Okay, sometimes in managing your forest, you don't really need to log. You're dealing with smaller trees, or you're just going to take out the understory smaller trees. You can hire a lot of different contractors that do that kind of work, and you just need to be clear when you hire them exactly what you want them to do, because some of them, I think, they go a little overboard, and I saw in my neighborhood there's some nice maple trees growing up. They're not a fire danger. These people just went through and cleaned everything out, and you could save a few little things that aren't really a fire hazard. So be clear when you make a contract with these people what they're going to do with the material. Are they going to chip it? Are they going to take it away? Just make sure you understand every part of it, because when you start taking trees down, you're generating a lot of material on the ground. And you just need to make sure that that's all addressed to your satisfaction before they start the project.
Awesome. Thanks, Dario. Great presentation. And up last, but certainly not least, we have our new district conservationist for the USDA Natural Resources Conservation Service here in Grass Valley. She has just been a breath of fresh air. She hasn't been with us very long. Pamela Hertzler, and she's got a great presentation here, because now that we've motivated you to manage your forest, we'd like to provide you with some cost share options. It does require that you have a management plan and whatnot, but she's got a great office and staff here in Nevada County that can help you get some assistance that you need. Pamela.
Well, thank you. Thank you very much, JoAnn. Wow, I feel like I'm the garage band coming on after the Beatles and the Rolling Stones, but I'll do my best. As JoAnn said, I am Pamela Hertzler. I work for the United States Department of Agriculture with the Natural Resource Conservation Service. I fairly new up here. I came up here 6 months ago from the San Joaquin Valley. I've been with the agency, well, with USDA since '87. First 20 odd years was in Tulare County, the last 6.5 in Merced County, and I've saved the best for last. I intend to stay here the rest of my working days, that's for sure. If you're not quite sure about who NRCS is, we do work with private landowners, and we have offices all around the United States. We have at least 52 offices here in the state of California alone. What we do is we help private landowners make conservation decisions. And so some of the projects that I've worked on in the past was up in the corner, we've got some processing tomatoes we help put in berry drip that is looking at the water conservation, especially in the San Joaquin Valley. You know, water is rare everywhere, but it's really rare down there. We also have up here, it's a micro sprinkler for almond orchard, going from flood to micro. Down here, this is right here in Nevada County that I got to work on right when I first got here, and that is an actual high tunnel or a hoop house that some people will call, and it's to help extend the growing season for your crops that are going, you know, from to the local restaurants around here or farmers market. And right here, I want to say this was in Mariposa County. We were helping with a reforestation project there. Little bit of history on who NRCS is. There was a little disaster in America's history called the Dust Bowl back in the 30s. And the topsoil was being blown to kingdom come. People lost lives, animals, livelihoods were just gone. And of course, there's the big migration that happened, that a lot of people came out here to California. There was a gentleman named Hugh Hammond Bennett who was a soil scientist at the time. And he saw this devastation that was going on, and it was all due to monoculture at that point. And just that one crop and the constant tilling of the ground. And he chose to go to Congress in Washington, D.C. and say, look, we need to do something about this to teach people how to utilize the land better. And he was able to time it at a point when he was in D.C. when a huge dust storm was coming over. I mean, from 100 miles away, it was covering Washington, D.C., and he was able to show these gentlemen of Congress at the time, this is why we need some sort of agency to help teach people how to utilize the land. And that's, we call Hugh here our godfather of Natural Resource Conservation Services, but at that time they called it Soil Conservation Service. So in '94, they chose to change our name to NRCS, Natural Resource Conservation, due to the fact that we look at all the resources, not just the soils. And we're looking at, of course, the soils, the water, the air, the plants, the animals. It's all encompassing. So soils is just a part of it. Of course, very important part of it. We need our soils. What I'm here to talk to you about is for cost share. And we have a program called Environmental Quality Incentive Program, or EQIP. You know, government's really good with all the abbreviations. Basically, these are fund pools that are under this EQIP. We get so much money from national, Washington, D.C., and that we are able to utilize this money to help people with projects on the ground. And so a lot of these projects, you know, I worked with a lot of dairies down in the San Joaquin Valley area. Of course, we don't have any up in here, but we help with any cropland, pasture land, rangeland. We've got quite a few projects going on up here for these. Water conservation, of course, and then the big one for right now is forest land. What happens with that is we have what's called a regional forest land fund pool, and that this is helping non-industrial forest land throughout the state, and this is to help your land to create a healthy forest. We call it the regional forest land, or we will call it a healthy forest cost share program, but it all falls under EQIP. How this works is we have, up here it's called the Sierra Nevada cluster, And we share this particular fund pool with these other counties up here. And some of the projects that we have done, there's more, but this is the main ones. Forest stand improvement, tree shrub pruning, woody residue treatment, fuel break, obstruction removal. So like what Dario was talking about, the thinning of the forest, getting in there and cutting down. We have some funds that could possibly help you get to that goal. Oops. There it goes. And here's a couple of pictures I threw up there. This is just showing before a thinning and pruning project, and this is the after thinning and pruning. And you can totally see the difference, you know, how we opened it up, and some of the pictures that Dario was showing. You know, this has opened up the floor. And so you're going to get that sunlight. You're not going to have that choking out of the forest, and you're going to remove that fuel hazard. That's the main focus here, too, is that fuel hazard. We don't want that. So now this other pot of money that you may have heard about, we have been given not here in Nevada County, but we have been given $4 million for California to focus on what's called the Tree Mortality Initiative. This is separate from our other regional fund pool. And this is to help with trees that are already stressed by the drought and the bark beetle, and they're dying or they're dead out there. And this is focused on removing the dead trees or the severely damaged on the private forest land. And what they're looking at is that more than 20% of your conifer forest land has dead trees on it. And so, I mean, if you're seeing your trees rapidly dying, this, you know, the big thing is we want to get those out of there so we don't have that huge fuel load. So, just a little something. I found this, I really like this. It kind of made me think of, you know, we've seen all the pictures of the bark beetle and the little baby guy. You know, how does something so small do this kind of devastation? And I think of it more like these large, like Godzilla-looking creatures. But it all comes down to thick forest plus drought plus bark beetles is a recipe for disaster. And this is, from this picture, you can't really tell how brown they are, but I want to say this is somewhere up in the Mariposa area, and it's, you know, here's this multi-million-dollar home with this beautiful green, but again, all this brown coming around it, and it won't be long before the rest of this is brown. And so it's really, you want to get those out of there so you don't have that devastation. It's changing our scenery, that is for sure. So at this time, the $4 million has been allocated for the tree mortality project, but the reality of it is we're sharing that with 18 other counties. And Mariposa County is considered ground zero. Around Fresno County area, if you're familiar with Shaver Lake, Bass Lake, I mean, those poor trees are just devastated. And now they've also added, we're the newest county to be put on the list, but also down in Southern California, they've put down Los Angeles County, which is the Big Bear area, going into that, in Riverside area, and also down into San Diego, into the foothill mountains there. So unfortunately, you know, $4 million sounds like a lot of money, but when we got to share it with all these other people, so we have, that's why I wanted to bring up both these fund pools, because it's, what we would do is we would sit down, we would work with you, we would want to come out and look at your property, see what's going on, and what would be the best area for us to put you in, what fund pool. The primary resource, of course, is related to the fuels hazard, and the main practices that you would be applying for is obstruction removal, was removing the trees, tree shrub pruning, and forest stand improvement, thinning. There are other practices, but these are the main ones that that people tend to get contracts for up in this area. To apply for the programs, you have to meet an eligibility with us also. First of all, you got to be an ag producer, or in this case, own forest land. You have to have control of your land, meaning you own it, and you would need to give us a deed to show proof of ownership if you're not established with us already. Or if you're living on the property, you're leasing it, or let's say you're living on Grandpa Bob's estate, Well, being that it's owned under Grandpa Bob, we're still going to have to see that you've got control of the land, so there will have to be some sort of a written up lease between Grandpa Bob and you, just to say that you've got control of the land. We don't need anything lawyered up, just something that says that yes, you have control of it, and that's why you're applying for these funds. Again, it's got to be non-industrial, private forest land, tribal land. Being that I'm fairly new in the area, I'm really not quite sure. I know there's some Indian tribes up in this area, but I'm not quite sure where. I haven't worked with any of them yet. And the other big thing is you got to be in compliance with our adjusted gross income, and that means they'll look at this fiscal year 2017, and they want to see for the tax years 15, 14, and 13 that you did not gross over $900,000. And we have this form you have to fill out, check off less than, more than, and this does go to IRS. And if perchance you did check less than, but it comes back that you did make more than, and if we ever paid you any monies, then unfortunately they would go back after you to get the money back. So you want to make sure that you're good with that. I hate going after people for money. The other eligibility is it's a 3-acre minimum, and that is with the dwelling. So if you got a house out there, minus the 100-foot defensible space. We cannot work in that defensible space area. If you need help with that, I know JoAnn with Fire Safe Council, they got some programs going on that may be able to help you. Also, a 1-acre minimum with no dwelling. 4 dead trees per acre is what they're basically looking at, and the funding percentage is approximately 50%. I didn't want to bring any dollars in tonight, being that they haven't given us our cost list for fiscal year 17 yet. We're expecting that at the end of the month, but it usually comes out to be about 50% of what you would be paying for somebody to take out the trees or to do the thinning. If you got to hire somebody, or a lot of people do it themselves. Unfortunately, the way our program works is you say you do the best case scenario, we get a contract for you. You cannot start your projects prior to getting the green light for, for getting approved for the funding. Because if you start your project prior to getting the approval, then that would be considered disqualification. So you want to make sure that you're funded with us first before you start. The other thing is that, oh, my mind just went blank, excuse me. Let's see. So for the way to apply is you want to come on in to the Grass Valley Field Office. We will help you determine if you will need to apply for tree mortality or under our regular EQIP forest land. I do have my business cards on the back table, so please get a business card and call me, call our office. Anybody in the office will be able to help you. We will help you navigate through the paperwork. It is government, unfortunately. That means there are papers, but we will help you navigate it. We hope that we can help as many people as we can here. There's other programs going on out there. CAL FIRE has what's called the California Forest Initiative Plan. That is to help also. It's something similar to ours, but I don't think they have as much paperwork to jump through like we do. I know PG&E has a program going on right now also that is helps if you've got trees that are getting ready to come down on lines or they're close to your homes. So you want to contact PG&E. I know Fire Safe Council has a wonderful website that has a lot of these folks up there who's out there to help you. So we're just one piece of the puzzle here for us to help. What we would like to do is we would come out to your property, we would walk your land with you, we would talk to you about what's going on out there, find out if, maybe there's some other things you hadn't thought of. We'll give you suggestions. We're a non-regulatory agency. I want you to know that also. We do not turn around and write you a ticket if you're not doing this right or that right. But if you do get a contract with us, we do expect you to follow the contract procedures and to be able to start your project and complete your project, and we'll work again with you throughout the whole process. Again, here's my contact info, but I have my cards out on the back, and that you can call me, email me, call our office. We're there to help you. And is there any questions? Yes. What is the difference between industrial and non-industrial forest land? Industrial would be, let's say it's owned by, what's one of the big, SPI? Yeah, that would be your industrial. Non-industrial is what you have out there. You've got your land, you've got your trees, you're not in the marketing business. You cut down a couple of trees and you've gone through the procedures like you're supposed to with the license to sell your wood, that's fine. Or you're sending it to the mills, that's fine. But industrial is because it's for profit, you know, whether it be for paper or whatever. Grant is paid before or after work completed. Oh, thank you. I totally glossed over that. Yes, what happens is when you first get your contract, you have to do the project first. And then after everything is said and done, and we'll be with you every step of the way if you got any questions, and after everything is said and done, we come out, we certify that the project is completed, and then we then process the payment. I tell people to look at it like a rebate program. You bought that computer, you got to turn in your box top with your receipt, and then you get that money afterwards. Again, it's a helping hand. We don't pay for the whole amount, but it does give you a little bit of money, hopefully up to the 50% to help you. And is there another one? Oh.
This one's really more of a calculator. It's got $4 million divided by the 18 counties, so $222,000 per county, and they're estimating at $1,000 per tree. That would equal 222 trees in Nevada County, or 444 trees at the 50% project cost share. And I think that math probably is pretty accurate. There certainly is not enough money out there to help everyone. But obviously those who are being proactive may get first in line to get some help. And this is only the tree mortality fund, not the total EQIP fund. So there is another pocket of money. So I don't know if you want to talk about how much is in the other pocket.
Honestly, they have not given us those numbers yet. So I cannot give you that. But that is something that hopefully by the end of this month, I will have those numbers. We have continuous funding through the year. We've got, it's going to be 3 what they call batching periods this year. We've got one that's coming around the corner, which we have applications ready to go, which is going to be December 12th is that batching period. But then we have a second one in February, and then we'll have another one in May, and then they're supposed to be adding another one on after that. But we will know how much money is actually going to be funded out of that Sierra County EQIP Regional Forest Fund pool by then. And it's usually, you know, that funding is easier for us to get to than right now competing with this tree mortality. And I think what's happening with the tree mortality, being that this $4 million was sent down here this way, I think they're wanting to show how many applications they get, of course, in the other counties, and that there's this huge workload. And when there's a huge workload, hopefully they'll send more money. And I think that's what's happening here. And of course, you know, we've got new president, new change of cabinet, new things are going to be happening. So everything's up in the air on how it will be. I know a lot of this is, well, all of this is under, especially our regular EQIP is under the 2014 Farm Bill. And that is in place through 2018. So what we have there will not change. What might change is how much money will come for the tree mortality program. I'm hoping they do send more money. But right now, that's what's happening.
Awesome. Thank you, Pamela. We did have a couple of more questions. Oh, let's give it up for Pamela there. Thank you. You got to give it up for the girl with the pocketbook. And we did have a couple of more forestry type questions, so our speakers will be hanging out a little bit afterwards if you care to ask them one-on-one about your forest and your management style. But Dario's got a couple of more forestry questions we're going to answer here.
Okay, got a couple of great questions here. One is, Once an area is masticated, how long until you have to do it again? Okay, that depends on the productivity of your soil. If you have a really good soil, things are going to grow back faster, obviously. But it also depends on the type of vegetation you're masticating. So let's say, for instance, it's just an understory of just thick cedar and white fir. Those things do not sprout back after you cut them down. So it's going to take quite a while. It's going to be probably more than 10 years before you'd have to come back. In the interim, you can cut it off by going through periodically and cleaning it out. You're going to have real slow reestablishment of those kind of plants. They're going to have to start from seeds. They're going to have to germinate and grow very, very slowly. So you have a chance to just go pull them up or cut them down with a weed eater. There's all other options in there. But if you're talking about plants that resprout, like some of the shrubs, the ceanothus, they're going to resprout very quickly, and depending on how much sunlight is coming in, you're going to probably be back in there doing something within 5 years. But it's always going to be, if you stay on top of it, it's always going to be a smaller, less expensive job than the initial mastication. Just the maintenance is always cheaper if you keep up with it. The other question is there a program to instruct homeowners in how to manage reforestation and to encourage native plant material rather than invasive species? That's a great question, because like I said, when you apply any management activities, there's going to be a reaction. Something's going to try to move into that opportunity, that open area. And we don't want Scotch broom, star thistle, and those things to take over. So the best way to deal with that really is if you've got any of those plants nearby, before you do your treatment, get rid of them, and then you just have to be vigilant that those invasive plants don't start showing up and pull them or spray them or do something right away before they spread. Unfortunately, sometimes we have neighbors that don't do anything, and the seed just keeps blowing onto our property. You can also, with a little more work, you can purchase some native plants. There's a native plant sale, I think twice a year, once in the Grass Valley, Nevada City area, and once down in Rockland, where you can purchase plants. People grew their native plants. You'd have to prepare a site for them, plant them, and make sure they get some water, at least initially, till they get established. But really, it's all about maintenance. Once you put all the money and work into clearing it out, don't just walk away and let it come back. Sometimes it'll come back awfully fast, and sometimes you have time, but just keep monitoring it, and you can steer the direction of how it grows back. If you're getting a lot of regrowth on shrubs you don't want, you can just keep cutting them down. Before they get too big, you can just cut them with loppers. If you got a whole bunch of cedars coming in, maybe you want a few, but you don't want that many, pull some of them out. Try to get them when the plants are smaller. They're just easier, cheaper to deal with. Okay. We've got another one here. Sure.
How long does it take mistletoe to kill oaks, and does mistletoe increase oak flammability in a mixed forest? Got it.
Okay. There are different kinds of mistletoe, and there's true mistletoe in oaks and other hardwoods, and then we have dwarf mistletoe. It's very, very similar in conifers, and they're parasites, but they also have green leaves, so they photosynthesize. So they're very, very efficient. They very slowly kill trees. It depends on how much of the crown is infected with mistletoe. Now, on hardwoods, when they lose their leaves in the fall, you can really see the mistletoe because it's about the only green thing. It stays green all year. So if a tree has like maybe more than 50% of the canopy of the crown has mistletoe, it's definitely a tree in decline. And sometimes what will happen is the mistletoe will catch a lot of snow and those branches will break. That can actually be a good thing for the tree because it's gotten rid of the mistletoe. The mistletoe is just right in that one area. You can hire people to go up and prune the mistletoe out. That can be very expensive. As far as a fire danger, I don't think it makes it really any more flammable. It's more important as to what's growing beneath it, if you've got a ladder fuel leading up to it. I don't think it's really a matter of flammability at all. Did that help?
Okay. We'd like to thank our three presenters tonight. They all did a great job. One more round of applause.